Multi-engine aircraft AC supply distribution systems will either be of the split busbar type, where each generator operates independently, or of the parallel busbar type, where each generator carries a share of all the loads. In this lesson, we will look at a parallel busbar type of system, as fitted to a 4-engine Boeing aircraft. Each of the four 115/200 volt, 400 Hz, 3-phase engine-driven integrated drive AC generators, or IDGs, is connected to its respective load busbar by a generator control breaker, or GCB. Busbars 1 and 2 can be connected to the left synchronizing busbar through bus tie breakers. Busbars 3 and 4 can be connected to the right synchronizing busbar in the same way. All loads are connected to the load busbars. The synchronizing busbars have no loads attached to them. The left and right synchronizing busbars can be connected together by the split system breaker. The auxiliary power unit, or APU, drives two generators. APU generator 1 connects to the left synchronizing busbar and APU generator 2 to the right. The APU generators do not have constant speed drive units, so they cannot be operated in parallel with any other generators. Two AC external power cards can be connected into the electrical system. One connects to the left synchronizing busbar and the other to the right. As with the APU generators, external power cards cannot be operated in parallel with any other power source. Operation of the system is almost fully automatic. However, there is a control panel which firstly keeps the pilot informed of the current configuration, and secondly allows him to override certain functions if required. We will have a look at the operation of the system and the indications the pilot can expect to see, starting with the aircraft stationary on the ground with no engines running. If the APU is running and the outputs from its generators are satisfactory, available lights will be illuminated in their switch lights. Similarly, if external power cards are connected to the aeroplane and their output voltages and frequencies are satisfactory, available lights will be illuminated in their switch lights. The pilot can connect one of these power supplies to the busbars by pressing its switch light. This will connect the selected source to the left or right synchronizing busbar. The split system breaker is normally closed, unless there is a fault, so the supply will also be fed to the other synchronizing busbar. The bus tie breaker, or BTB switch lights, are normally latched in with auto-illuminated. In this position, the BTBs will remain closed unless there is a fault. Therefore, the selected source will power all four load busbars through their BTBs. If an APU generator or external power supply is connected to the other synchronizing busbar, then the split system breaker, or SSB, will automatically open to separate the two sources of supply. Each of the four engine-driven generators has a generator control switch light and a guarded drive disconnect switch light. Each drive disconnect switch light has an amber drive light which will illuminate if its associated IDG oil pressure is low or oil temperature is high. The guard can then be raised and the switch operated to disconnect the IDG from the engine. Remember that the engine must be running at a minimum of idle RPM before this action is taken. At the moment, the drive lights are all illuminated because the engines aren't turning. Each generator control switch light has a white on light and an amber off light in it. With the switch light latched in its normal position, the on light will be illuminated. In this switch position, the generator control breaker is armed to close when the generator output is within limits and to open when it is not. The amber off light monitors the position of the GCB. It is illuminated when the GCB is open. The pilot will first start number 4 engine. As the engine accelerates and the IDG begins to rotate, the IDG oil pressure will rise and the drive light in the disconnect switch will go out. When the generator output voltage and frequency are within limits, because the APU generators or external power cannot be operated in parallel with the engine-driven generators, the automatic control system will first disconnect the APU generator or external power from the synchronizing busbar, and then close the number 4 GCB. Number 4 generator will now supply its load busbar, and through its BTB the right synchronizing busbar. From here, busbar 3 will be supplied through its BTB, and the left synchronizing busbar through the split system breaker. Busbars 1 and 2 will be powered from the left synchronizing busbar through their BTBs. Thus, generator 4 will be supplying all of the loads. As each subsequent engine is started, the output voltage, frequency and phase rotation of its generator are adjusted to align with the voltage, frequency and phase rotation of the generator or generators already supplying the busbars. And when all are aligned, the associated GCB will close, allowing the generators to operate in parallel. The APU will be stopped and external power will be disconnected prior to taxi. So with all generators operating normally, the control panel will look like this. In the event of a fault on an individual generator or an engine failure, the associated GCB will automatically open and the other in-parallel generators will carry the load with no loss of supply. If there is a short-circuit fault on a busbar, the breakers surrounding the faulty busbar will automatically open to isolate the area with the short circuit. A short circuit on the left synchronizing busbar, for instance, will cause the split system breaker and bus tie breakers 1 and 2 to open, isolating the affected busbar. The system is almost completely automatic. The pilot does not normally make any selections apart from selecting the APU generators or external power on. If it is required, he can latch out any of the GCB or BTB switch lights, locking the associated breaker open. You will notice that there is no indication on the control panel of the status of the split system breaker. It is, however, possible to view a synoptic of the system on one of the aircraft's electronic screens, and this includes the SSB. This picture shows the system operating normally with the SSB closed. The synoptic display also reflects any abnormal system configurations or faults. In this example, number 3 bus tie breaker is open, and number 2 IDG has either a high oil temperature or low oil pressure fault. DC loads are supplied from transformer rectifier units connected to the load bus bars. Emergency AC power is provided by a static inverter supplied by the aircraft battery and emergency DC power directly by the battery. These systems are connected in much the same way as in a split busbar system and are fully explained in the split busbar systems lesson. That is the end of the lesson. Here is a summary of the main points. The generators are connected to their load bus bars by generator control breakers. The load bus bars carry all of the loads. Bus tie breakers connect the load bus bars to the synchronizing bus bars. The synchronizing bus bars are connected together by the split system breaker. APU generators or external power supplies cannot be operated in parallel with any other power source. The output voltage, frequency and phase rotation of each generator is adjusted to align with the voltage, frequency and phase rotation of any generator or generators already supplying the bus bars before it is allowed to connect to the bus bars.